Hey, welcome back. In this video, we're going to be talking about congruent triangles coming up. So before we start talking about congruent triangles, let's consider congruent shapes in general. Two figures are congruent if they are identical in shape and size. They do not need to have the same orientation. So here you can see these two shapes are congruent. One is just a rotation of the other one. Furthermore, two figures are congruent if the figures are equiangular and the corresponding side lengths are equal. So here you can see that the two shapes are congruent. They're the same size and have the same angle property. They're just a rotation of each other. The figures are equiangular and the corresponding side lengths are equal. So moving on to discuss congruent triangles. Two triangles are congruent if they are identical in every aspect apart from position. If we were given instructions to construct a triangle with three lengths, 6 cm, 5 cm and 3 cm respectively, there is only one way that we can construct it. So if I were to give 30 people the same instruction, everyone would draw the triangle like this. However, if we were given the measurements of three angles of a triangle, we can construct it in more than one way. So everyone will draw a triangle, possibly with different sizes. Although they're equiangular, they do not have the same corresponding side lengths. There are 4 rules for producing congruent triangles. Two triangles are congruent if any of the following is true. All corresponding sides are equal in length, so we can abbreviate it to SSS, side, side, side. So these two triangles are congruent since each corresponding side has the same length. The second instant, two sides and the including angle are equal, so we can abbreviate it to SAS, which is side, angle, side. So here we see that this corresponding side with this one here is equal, the including angle should be equal, and then the second corresponding side should also be equal. That would produce two congruent triangles. The third statement, two angles and a pair of corresponding sides are equal, which can be abbreviated to AAcorS. So angle, angle, corresponding side. So here you can see we have an angle, and then we have, of course, the same angles in the second triangle, and the corresponding side is equal. Therefore, we produce congruent triangles. And lastly, for right angle triangles, the hypotenuse and one pair of sides are equal. We can abbreviate that to RHS. So the right angle, the corresponding side is equal, and the hypotenuse is equal. So let's look at a question. Are these pairs of triangles congruent? Give reasons why. So we have A, B, C and D. You've got 4 questions to answer. I would suggest pausing the video here and attempting to solve these yourself. Look back at the previous slide where I indicated the rules, or refer to your copybook where you copied them down. So have a go on your own. Make sure you give reasons as to why each pair is congruent or not. So you may have noticed that the first pair of triangles are congruent because they're right angle triangle, the hypotenuse are corresponding, and then the same corresponding side is equal. The second pair of triangles are congruent because side, angle, side, and then the corresponding side, angle, side are the same. You may notice for C that they're not congruent. They may look like two equal angles and then a corresponding side. However, if you look closely, in triangle 1, angle alpha should be the same as angle beta. They're in the wrong position, and angle beta in triangle 1 should represent angle alpha in triangle 2. So that doesn't match up. So be careful of tricky questions like this. Finally, for D, yes, they are congruent, and this is a proper example of angle, angle, corresponding side. If you rotate the second triangle anti-clockwise by 90 degrees, you'll notice that alpha is equal to alpha, beta is corresponding to this beta, and then the corresponding length of 4 is the same as this one here. So let's look at another question. Are there congruent triangles in the given figure? If so, what can be deduced? So in triangles PQN and PRN, the first thing that we can deduce is that the length PQ is equal to PR. We know this because they've given us a double dash on PQ and a double dash on PR. So we know that PQ is the same length as PR. That's given information. Secondly, the angle PNQ is equal to PNR and is 90 degrees. Again, that information is given to us. So PNQ, this is 90 degrees, and then PNR is also 90 degrees. The third point is that the length PN, this dotted line here, is common for both triangles. So PN is common for both PQN and PNR. So therefore, triangles PQN and PRN are congruent using RHS. They're right angle triangles, the hypotenuse are equal, and then the corresponding side is also equal. The remaining corresponding sides and angles are equal. And so that means that QN is equal to RN. The angle PQN is equal to PRN. And finally, the angle QPN is equal to RPN. So QPN is the same as RPN. Now, when it comes to dealing with questions with congruent triangles, you have to be able to prove that the two triangles are congruent. So make sure you're familiar and you remember the 4 rules for congruent triangles. Side, 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 angle, side. And the trick to this one is because the angle is included between the two sides. And then you have angle, angle, corresponding side. For right angle triangles, the hypotenuse and another corresponding side must be equal. So that's it for this one. And if you have any questions, leave them in the comment section below. As always, thanks for watching. If you found the video helpful, make sure you drop me a like, and I'll see you in the next one.